matter that we don't get through all the lecture material, because truly, I've been doing this course since 2011. The lecture material gets longer and longer. I don't take anything else out. So we will not get through it. It's for you to use in the context of your lives, and we will talk about that. But we are going to go through a scenario first. So picture in your mind that it is the year 2035, and you are much younger than you are. You're a kid named Billy. And it's your day off school, and so you do what any kid wants to do. You decide to play a game. And what you do is you slip on your augmented reality headset, and you decide to play a game called, well, we won't tell you the name yet, but basically you get to shoot bad guys. And you take your laser gun and you zap all of these alien invaders, and you do so until you've won the game, and then you take off your headset. But in actuality, what you have done is you have been blasting cancer cells. And so, is this so far-fetched? I'll leave it to you to decide by the end of this lecture today. But you play this little game called the Tumor Neighbor. Okay, so I appreciate those of you who laughed at that. Today we're going to be talking about engineering the future that you want to see and your role behind that. And how we foster cultures of innovation and disruption, and what kind of frameworks we can use to help us get there. Okay? So by the end of this, come on in, you haven't missed much, you're about 30 seconds into this lecture. So by the end of this lecture, I want you to know the what, the why, and the how of the innovation, and how that applies to your trajectory within whatever it is that you're studying specifically, okay? So I want you to have a sense of what emerging trends and technologies are out there, and this changes all the time. As they pertain to innovation and medicine, I want to introduce you to some of the greatest challenges we face in medicine, and again, this is always changing. How to get into an innovation mindset, and then figuring out how to empower yourselves to enact change. Okay, so again, to summarize, I want you to know what is innovation, why it matters, and how we get to becoming innovators. Okay, so this is going to be super interactive. Do not be shy, because otherwise I will pick on folks. What is this? Not bottle, perfect. Not a trick question. Okay, so second question. What is it used for?
Store liquid.
Okay, perfect. What else could it be used for?
Those soda rockets.
That's great, I love it. Space application. Okay, what else?
To drink from.
To drink from, okay. Anything else? Be creative. Be as creative as you want.
There is no wrong bat.
That's great. I haven't heard that one before. That's perfect.
Like make those like boats that like float. That's what
This is great. Yeah, this is awesome. I haven't heard any of these suggestions before. Anything else?
The plastic could be melted to use.
Great, repurposing things. Okay, so here's what others have used it for: as planters, as chandeliers, bird feeders, jewelry, storing devices, pencil cases, art installations, and piggy banks. So basically, the limitations of a bottle is basically the limitations that you put on it. Okay, and to someone's point about repurposing a bottle, you can also re-engineer the bottle to be better. Because if you are super neurotic like me, and you think way too much about these things, and you think about all of the bottles that end up in landfills every year, and the minuscule amounts of milliliters that remain in a bottle, over time that adds up to millions of liters, if not more, of waste. So what happens if you re-engineer the bottle to be different in its adhesive properties to what it contains? So someone did that at MIT Media Lab not too long ago. Let's see if this will work. Maybe? Oh, okay. It's kind of, you guys cannot see that at all. Let me figure out how to make that bigger. If not, can you kind of squint if you see that? Okay, so basically that was a traditional bottle, and how the ketchup was getting stuck. So what they did was they re-engineered the bottle, so there's almost no adhesive force between them. So now you can get all of the product. Yeah, that was my reaction too when I saw that. So that's just simply one way of thinking of innovation. And so it kind of ruins the whole Heinz ketchup marketing gig with slamming the bottle. But, now it's not good. Okay, get rid of that.
Have you ever done taking your toothpaste tube and had to squeeze out and roll up the end to get that last bit of product out?
Yeah, so I'm actually fastidious about that.
Yeah, I had to do that this morning.
It's terrible. You lose much.
Everybody, you to take these two products in your hand, pull you out what is this?
Yeah,
Every year,
sorry.
I'll get you to bring me back.
Okay.
One of these years, I'll just bring my own laptop. Or learn math.
All right. So.
Do you want these slides to email to us? Sure. Do you want these slides to email to us?
No.
They're not?
They should have been just before class, at about 1:20.
Okay.
So if you check your emails, and if not, they will be available to you after class. But I did see an email from Kim Go outside.
So.
Perfect. You don't have it in your email?
I don't know.
No, in the
No, I didn't
Okay. Well,
send it. I was in the process of it. but I-
apologies. So typically I'll try to send it out before class, but you will have it after class. Okay. So, getting to this idea of innovation. Okay. So we're going to talk more about that. We're going to spend the whole hour and whatever time we have left talking about that. But I'm sure you guys want to know who I am, why I'm talking to you about innovation. So as I've alluded to, I've been teaching this class since 2011. Kim, Dr. Solis, was kind enough to ask me after we met at Singularity University, which is a place where you learn to think exponentially and disruptively. So I wear a lot of hats. I am a assistant clinical professor here with the Faculty of Medicine and Dentistry. I'm an emergency medicine physician in rural medicine as well as aeromedical transport. And as you will see, I do a lot in the space sphere. So I am a commercial astronaut, I am an entrepreneur, and gosh, there's so much more. I'm an aquanaut, an explorer, and I do a whole bunch of research in space medicine and novel technologies as they both pertain to astronaut health in space and are most in need resource-limited environments on Earth. Okay, so that's me. That's the written version of everything I do. You will have these in your slides. There are no financial disclosures, but where I have commercial affiliations with companies that I advise, I will make it clear. Okay, so that's me. Now it's your turn, so we're going to go around the room. So I want to know who you are, what you're studying, what brought you to this course. Go ahead.
Yeah, I'm Don. So I finished my MD and now I'm doing my Master's and Fellowship in the University of Alberta.
Perfect.
So it's my studies in spinal cord injury.
Great, perfect.
Yeah, and we are doing another technology to activate the spinal cord injury below the level of injury
Wow.
using intraspinal cord electrical stimulation.
That's fabulous. How's it going?
It's going so well.
Great,
So,
great. And you had messaged me, I think. before
Yeah,
this. Perfect.
yeah.
Okay, I remember. Next.
Okay, my name's Janine, and I am an undergraduate student. I am in biology, and I do cell biology research, where we study cancer cells. And the way I heard about this course is through a friend, and she knows that I'm interested in science and research and things like that, and she pointed this course out to me. So.
Great, perfect.
I'm Barbara. I come from Italy.
From where?
Italy.
Italy, okay, great.
Yeah, I've done my master degree there, but I came here at the U of A because of my professor. He teaches in both universities,
Great,
and now I'm doing my PhD here.
great.
I'm in biomedical engineering,
Perfect.
and my project is about electromagnetic fields on cancer cells. So yeah, this is my field of application.
Super cool. And what have you found so far about electromagnetic
So I'm studying in particular some changes in the structure of proteins involved in the cytoplasm, like actin and tubulin, and also mitochondria. And in particular, there is a quite interesting boost of energy production. And it's very intriguing because if we are trying to see if this involves also neurons, and if this is true, there might be some quite interesting therapeutical approaches for neurological diseases. So we are seeing if we can have some good results in that.
That's fantastic. So I'm glad to hear there's a lot of cancer research going on. There will be a couple slides dedicated to that. Go ahead.
Hi, my name is Jessica. I recently graduated from the Faculty of Science, majoring in psychology. So right now I'm just taking a gap year and continuing my research. And I research stroke, using animal models, so usually rat models. But what brought me to this course is my friend Daniel, actually. He really enjoyed this course last semester and recommended it to me this semester, and now he's a TA for it. So
Perfect, great.
My name is Caitlin. I'm in my undergrad for bio. I'm not doing any research right now. Keeping my eyes open, seeing what I'm interested in. I'm really interested in microbes and applications for like global warming and for that sort of thing. Sorry, I'm a bit distracted. I joined this course because I got a lot of good recommendations from previous friends, and it's really applicable to a lot of my friends in comp sci. So just looking into that a bit more, yeah.
Fabulous.
My name is
Sorry,
Ryan.
Ryan.
Yeah,
Okay,
I'm a
great.
second year neuroscience student, and I was really interested in this course because just in my personal time, I'm really interested in like AI and like just that whole aspect of it, and I wanted to go to experience medicine and kind of just ties both of them together.
Perfect.
So I'm really interested in how medicine is going to change with AI because I've seen already like how fast it's growing and it's going to grow
Yes.
even faster.
Perfect.
So that's the main thing that caught my attention.
Okay, so great. So biomedical engineering, a lot of neuroscience, a lot of cancer research, a lot of microbial research, and AI. There hopefully will be something for everyone in this lecture, and if not, we will add to it. Okay, so let's start answering the 3 objectives we set out to answer this course. Side note, I am terrible with names, so if you guys could just tell me your name anytime you have us raise your hand and say something, I will eventually hopefully get it. Okay. So what is innovation? So if I were to throw this question back at you, how would you define innovation, Ryan?
I would say innovation is like thinking of something or making something that hasn't been like made before, and like rather than like repeating a process, you're kind of starting from scratch and building your own.
Okay, so starting from scratch. Jenny?
I would say it's it's kind of an expansion of what we know.
Okay.
It's like creativity in
Okay.
what we have.
Being creative and building upon what we know. Done.
It's a problem solving process
Problem solving.
which
excellent.
will like shorten the answer, like the pathway to the answer.
Perfect. So the truth is, all of those things are true. Okay. So we build upon things that previously existed. Dating myself a little bit here, but back in my day, Windows 95 was the thing that people lined up for around the corner and stayed awake until 1 a.m. to await the launch of. And a few years ago, when I was updating this, it was Windows 10 and now 11, and I don't know where we are now. It's evolving from, again, dating myself, from Walkmans to Discmans to iPods to iPhones and tablets, and then building upon that and making our phones bigger and our tablets smaller until they become the same device. It's also doing things completely differently, taking innovation and ideation from science fiction. So some of you might be saying it's 2025, where's my flying car? There are actually multiple companies working on that. So when I first started teaching this course, there were maybe 1, maybe 2 examples of that. Terraphagia was always the example I cited. Since 2021, the FAA has received multiple certification applications for hybrid cars and flying vehicles. There's companies out of Eastern Europe, out of China, that are seeking to have hybrid car flying vehicle models. So this is from CES 2024. This is one of the examples of a hybrid roto-car vehicle. And when we talk about innovation, it's not just taking brand new technologies, but it's also conceiving of new applications for them. So drones. Drones are a novel technology that have been on the scene for about 14, 15 years, at least in more widespread dissemination. So drones for food delivery, drones for toys, drones for photography, for delivery, and now medical delivery and medical devices to austere and remote and resource-limited locations. It's also creating things that we may not know we necessarily need. So this is out of Stanford Innovation Labs. And they thought, what if we could make your furniture smart? And so they programmed ottomans to let you relax when you didn't know that you needed to relax. Okay. It's, again, to this idea of making new applications for novel technologies. So 3D printing, additive manufacturing, there are multiple applications, and we're going to talk about the applications within medicine, but broadly speaking, this here is gross but fascinating. So someone somewhere modeled the projectile of a sneeze. So the mucus particles as they go through the air and then turn that into a 3D model, which turned into a vase, which is now an art installation. So the idea of a sneeze in and of itself may not be tasteful or maybe distasteful to you, but that's pretty cool art, I think. So there's also 3D printing for food, so you can have your face and eat it too. 3D printing for, we will talk about this for tissues and biotissue printing, and we'll also talk about what 3D printing in space looks like, probably during the space medicine lecture. So that's being done since 2009. Made in Space was the first company to prove that it could be done, more so with tools and parts. And now we're finding that 3D printing in microgravity or zero gravity has advantages over trying to do that in 1G. And of course, 3D printing for prosthetics. So this is a turtle with pyramidalism, and it was missing part of its shell, so they gave this little guy his best life by giving him a shell again. Here's some examples of novel materials engineering. So this is, a novel polymer. Let's see if this will work. Usually it's a video. Yes, okay. So I'll just let you watch it and we'll talk through it. So I know someone had mentioned climate change applications in their introduction, and so this is a novel, this is an example of novel uses of material science. So this is a polyurethane polyimide that can be used for oil spills, which are historically environmental disasters, can affect marine life, can be a loss of oil. So now you have something that is lightweight, can soak up 90 times the oil spill, be wrung out so the oil can be used, and is also reusable. So. Oh, sorry, I should have warned you guys, there's already photos in this. This is an example of surgical innovation in surgery. So this was a Chinese factory worker who tragically lost his hands in a factory accident. And so they debrided the stump, and then they felt his hands were still viable. So to keep the blood supply to the hand going, this had never been done before. They thought, okay, well, what if we can keep the blood supply to the hand going? And then once the stumps were adequately healed, for regrafting the hands. So again, first, medicine is constantly evolving, and as you'll see towards the end of the lecture, the way that we get to creating innovations and new ideas is looking for building on new models, building on existing innovations, but also thinking about how we can make things better. Yes?
Sorry, what was the point of keeping the hand if it's just on the leg?
Oh, so if you don't, you want to keep the hand viable, and so it needs to have a blood supply. And so the reason they grafted it to the leg was by giving it its own blood supply, so redirecting the blood flow from the leg while keeping the leg viable as well.
So can it be like put back or what?
Yes, sorry, so that's what sorry, that was a lot of jargon. But basically they wanted to keep the hand living so that once the stumps of the wrists had adequately healed to be able to take on a graft, they could regraft it. Yeah.
So what if they want the hand not to, like the graft not to heal before they apply it on, just because if it's healed, it's like scar tissue?
Yeah, there's a sweet spot. So you don't want the stump completely healed, but also there's probably a lot of nerve damage, a lot of tissue debridement. Like the stump needs to be cleaned up as well. I can't imagine it was a clean trauma. Yeah, and so the great thing about this lecture is I get to keep updating it. So as of the last couple of years, we have seen the first xenotransplant, so the first pig to human heart transplant. Unfortunately, that recipient passed away. I think there were some issues of non-compliance. And then in the last few months, there was also the first eyeball transplant, which again hasn't been done. So this is a really exciting time to be alive. So you're going to see me inject a lot of space into this because that's what I do. So once upon a time, the only way to be an astronaut was to go through through a space agency selection, through the Canadian Space Agency, the European Space Agency, through NASA. And since 2021, that has been changing. So we've seen the rise of suborbital spaceflight with companies like Virgin Galactic, who I will be flying with in 2026. and Blue Origin. So those are those very, very, think of the world's highest roller coaster where you go super high and get a period of microgravity in which to do your science and research. We've seen all civilian missions go to orbit with the Inspiration 4 SpaceX mission in 2021, and Jared Isaacman went on to do a second mission, Polaris Dawn, in last September. We had some research aboard that mission, and now he is the new incoming NASA administrator. And so, this new access to low Earth orbit actually breeds the way for a lot of cool new research. So, I've put the links here. This is something I'm so excited about. So, pharmaceutical development. There have been companies, that needs to be plugged in. There have been companies experimenting with crystal protein growth and development in zero G, and specifically as it pertains to pharmaceutical development. And the reason is, in a zero G, is there anything I need to do here?
No, it is plugged in, I guess maybe it's not.
I'm gonna check all the,
Yeah, one. Is it
This one.
plugged in there?
so that, I wonder if that outlet doesn't work.
So, we can,
The closest one, I think it is.
just,
Perfect, okay, so back to drug development. So in the zero G environment, proteins can grow larger and more symmetrically and more smoothly. So this has been an area of research since the 70s, 80s, like since the shuttle era. But building upon what we know, now we've seen some real breakthroughs. So who here's heard of Merck, the pharmaceutical company? They're a major pharmaceutical company. They've developed vaccines. So in the past 2 years, they sent Keytruda, which is a very well-known chemotherapy agent. It's used for cancers like cervical cancer, melanoma, mesothelioma. And what they did was they were able to generate a version of Keytruda that is so shelf stable. Currently, as a patient going into a hospital, you need to spend a day in the hospital getting this infusion and spending hours there, and it's an IV infusion. So your quality of life is affected, healthcare costs with this soar, and it takes a lot of hospital resources. This new version of Keytruda has different viscosity properties such that it is more shelf stable, and so now you can actually inject it as an under the skin injection. So if you are a patient who is trained to do this, you can do this at home. This doesn't need refrigeration, or you can simply do it at your doctor's office. So the healthcare savings, the healthcare resources saved, and most importantly as a patient, your quality of life is impacted. And this came from space. And so the story goes on because the costs of drug development in space are still quite astronomically high. And so what they've done is they've taken these insights in the manufacturing process and they've brought them back to their Earth-based manufacturing processes, which is advantageous for them because their patent on Keytruda was expiring in the next year or so. And it also gives the next generation more convenient, accessible drug. So that's one of the applications for drug development in space and an example of innovation in space medicine. So let's look at other areas and emerging parallel technologies that may be outside of medicine. So since 2020, we've seen tech giants like Facebook, Meta, invest into AI, augmented reality, virtual reality, and so we're seeing applications of this for diagnostic imaging, for training and simulation. You'll learn in one of the later lectures that I work with a Canadian company called Luxonic Technologies. We leverage augmented reality and virtual reality to create diagnostic imaging workflows in virtual reality, as well as simulation and training for medical procedures for astronauts and for healthcare providers. Blockchain, cryptocurrency, so this wasn't a thing that existed when I started teaching this course, but the security elements of blockchain isn't just applicable to currency, it has applications for security outside of banking and potentially in healthcare. Okay? And then we heard a lot about applications for AI. So if you're interested in how AI is impacting healthcare, I fully encourage you to sign up for Dr. Penguin. Eric Topol, who's a leading voice and commentator on healthcare, him and his team at Harvard put out this weekly newsletter, which is a summary of all of the emerging insights in AI, everything from diagnostic imaging to facial recognition to voice recognition. And then here's a link from McKinsey on AI for healthcare in Canada. So the links are there in case you are interested. Okay, so this is just a whirlwind top-level view of what is out there. So let's go a little bit deeper now and talk about operating frameworks and how we think about healthcare in Canada. What are our guardrails and what are our constraints? Okay, so if I were to ask you to define health, sorry, remind me of your name?
Mine?
Yes.
Barbara.
Barbara.
Yeah.
Okay, what is your definition of health?
It's like the condition of the human being, like physical and mental condition of the human being. Yeah.
Okay, great. Jessica, anything to add to that?
In terms of like just the word health or healthy? Or just
Sure, both.
like, because to me like health and healthy, like health is like, I guess like the condition of one's like whole, like all like homeostasis and all that, but then being healthy is like, I guess in the sense of being like self-sustainable and like in terms of all internal systems and all of that.
So I like how you guys phrase that, because most importantly, you didn't say it's not being sick, because the World Health Organization definition of health talks about health as not simply the absence of disease, but the presence of physiological, physical, mental, and I would add sexual well-being. And so it's going to be really important as you talk about innovation. Maybe we don't need to just talk about keeping people healthy, but what about human enhancement? And so we'll get into that a little bit later. Okay, so then when we look at other helpful frameworks, the NIH, the National Institute of Healthcare, and in the US, they talk about the 5P model. I would add that there is a bonus 6P. So they talk about predictive healthcare, personalized, preventative, precise, participatory. So letting the patient have a voice in their own healthcare, and I would add point of care. So that is miniaturizing healthcare diagnostic applications to make them more accessible. So one example of this, one perfect example, is the availability of rapid COVID tests and being able to diagnose yourself at home. Okay. Does anyone here want to be a doctor? You're already a doctor. Does anyone else here want to be a doctor? Who doesn't want to be a doctor?
A lot of people.
Okay, so then this you will either come across this, have already come across this, but this will be important. If you are a practicing physician in Canada, sometimes at the interview back in my day, they asked you about this. These are the CanMed competencies. So what it takes to be constituted a medical expert in Canada. It means that you're a professional, you're a communicator, you're a leader, you advocate for healthcare, you're a scholar, you keep abreast of the latest guidelines, you also may do your own research, and that's what it takes to become, and you collaborate, you play nice with other fields and disciplines, researchers and healthcare professionals. So that's what it is defined as a medical expert under the CanMed's competencies. This is the World Economic Forum and how they define the framework of emerging healthcare technologies. So they talk about smart care. So that kind of ties into predictive care. It was part of the NIH model. Care anywhere. That one's going to become important as we talk about foundations of healthcare in Canada. Intelligent health enterprises and empowered care, and that kind of ties into participatory healthcare with patients. Okay, so this kind of was alluded to in the last slide, but when we talk about principles of healthcare in Canada, it must be accessible, portable, comprehensive, universal, and publicly administered. So that means if I have a healthcare issue but I'm a patient in Newfoundland, my healthcare status in Alberta guarantees that I will have access to healthcare in Newfoundland. So that's accessible, portable, and it means that there's no exclusions to that. It's comprehensive. So what I would get in Alberta is what I would get in another part of Canada. Okay, and then the principles of medical ethics. So we all heard of do no harm. So that actually translates into 4 pillars of healthcare ethics: non-maleficence, beneficence, autonomy, so practicing letting the patient make their own medical decisions, and justice, doing what's in the best interest of the patient. Okay, so this is a lot of information. I'm not expecting you to memorize it. At any midterm questions you'll get from me will always be open book, because I want to see you think critically and build on information you're given. I don't expect you to memorize anything. Okay, so these are all just guardrails, okay, for your information. Okay, so let's talk about challenges in medicine and opportunities. There's a lot, especially since every one of us here has lived through the pandemic, okay? And so that has evolved or devolved into COVID variants, into double pandemics into triple pandemics. So this time of year, it's always some combination of COVID, RSV, influenza, and now we also have avian bird flu to contend with, hooray. Accessibility and healthcare system collapse. So what we've noticed in the pandemic, and this seems to be universal, like regardless of whether you're operating in the healthcare system framework in the States, or in the UK or Canada, actually every one of these systems are overburdened. We're seeing higher volumes of patient and also higher acuity. So if you want to solve a problem, that's a good one to solve. And part of it is having better preventative health care. So treating a patient with advanced, poorly controlled diabetes, as well as all the complications that come with that. So eye problems, foot ulcers, infections, amputations. That is one thing. But if we could have an early warning system to see who is at risk of diabetes and even getting control before they progressed into diabetes is critical. So part of that is monitoring and then extending those same capabilities that we would have here at the biggest hospitals, the University of Alberta Hospital, and bringing that to remote and rural healthcare. So 100% of my practice will be in rural emergency medicine and now aeromedical transport. And so when I'm phoning the city about a critical patient, I will not have a CT scanner, I will not have an ultrasound. I often have to wait days for some of my labs to come back, whereas they would be back here in hours, compared to in the city. We're going to talk about some case studies with antibiotic resistance. So I know there was some interest in microbial research, and then we'll talk about all of these last 5 in terms of case studies. Okay, so any questions so far? So to kind of give you an idea of how opportunities and challenges keep evolving rapidly, I feel like the rate at which we just live and exist has been accelerating since the pandemic, because in 2020 and 2021, our innovators were thinking of brand new masks, and we were racing, and actually I think the story of how we got globally available mRNA vaccines and rolled them out, while there were a lot of lessons learned from the pandemic, the fact that we were able to go from pandemic to vaccine in the time we did is actually quite inspiring. So then in 2022, we had to deal with variants and then the social resistance against masking, and then what masks are the most protective against COVID and COVID variants. Then in 2023, we had to deal with the triple demics as well as the denial that came with that, so RSV, COVID, influenza. Last year it evolved, or the opportunity and the crisis. So the opportunity was getting point of care tests that could both check not just for COVID, but for RSV and for influenza. So this became available in Europe. I haven't seen it in North America, but as we alluded to, the healthcare systems are on the verge of collapse, if not pretty much collapsed already. So in 2025, let's lighten the mood a little bit and not talk about the crises, but let's talk about the opportunities. So if you're not using ChatGPT already, who here has used ChatGPT? Okay, so perfect. Okay, so it's been really fun teaching this course since ChatGPT became a thing, because it's kind of a gut check against what I have typically taught in this course, and there's actually a lot of concordance. So I asked ChatGPT what it thinks the emerging opportunities in healthcare and AI are in 2025, and I've just screenshotted it for you, but we've talked about this. So we've talked about medical imaging and diagnostics and personalized medicine, telemedicine, monitoring, virtual health assistants, robotic surgery. So there's a lot there, and this list is by no means comprehensive. I just asked it for 10 suggestions. And so the nice thing about how ChatGPT has evolved is you can actually pull on these threads and it will contextualize them based on your work. Okay, so, and this is kind of, does anyone know about Watson? Okay, so Watson, for those of you who don't know, was very early AI. So this is kind of 2010 era when Microsoft created this AI and thought that there would be applications for healthcare. And actually what ended up being the best application was Watson going on Jeopardy and kind of outranking and out-competing all of the contestants. So as you can see here, Watson kind of blew everyone out of the water. That's Ken Jennings, who's a famous Jeopardy whiz. Except, does anyone know how Watson met its end on Jeopardy? So the question was, what is the capital city of Canada? And we all know it. Watson lost out when they named Toronto as the capital of Canada. So AI at that time wasn't perfect, and AI at this point still isn't perfect. So it's important to be aware of the pitfalls of where AI hallucinations and misinformation and inaccurate models can steer us wrong, especially in healthcare when lives are at stake. Does anyone here watch Last Week Tonight, John Oliver? So they have a great episode. Maybe I'll create a slide for future versions of this when they talk about the perils and pitfalls of AI. And so one of the very interesting, very good models of how they cited biases in healthcare with AI is with skin cancer diagnosis. So what they noticed is that anytime there was a ruler involved with a skin pathological specimen, the AI was more likely to name that as a malignant skin tumor or cancer. And obviously the bias is if you're measuring it, you think that there's something wrong with that specimen and there might be a cancer there to diagnose. And AI picked up on, oh, the ruler's an indicator that there might be a malignancy. And obviously there's a bias there. And so then the other bias is with different skin types. So we see all different skin types in this room, but if we're training our models on a very specific type of skin complexion, then there's also room for bias. So it's important to be aware of where AI can steer us wrong. Has anyone had that example where AI has been just totally off base? Anyone?
Yeah.
What do you want to share?
Like I remember, like it was a long time ago when ChatGPT first came out.
Yeah.
I would like even simple math questions, it would get wrong.
Oh, interesting.
Yeah, and like I would like ask it like, oh, why isn't it this? And then it would say, sorry, it is this. Let me do it again, and then it would just do the exact same thing. So then it wasn't very accurate, but it's getting better. So.
Yeah.
My boyfriend's in software engineering, so this is very prevalent for him because he uses AI a lot to check his work.
Yeah.
So sometimes he asks, like, hey, I'm looking at this bug, I don't know what's going on, there's no answers. They give him an answer and he's like, no, this created more bugs, I have more problems, and it just keeps going. And he usually figures it out, it's usually just a comma, but they never usually point that out at first. It's always something such a deeper problem. But yeah.
So in order to check yourselves, how do you approach your interactions with ChatGPT?
Sorry, can you ask the question again?
So in order to, because it seems like all of us are aware of the pitfalls of ChatGPT, does anyone here have a strategy that they wanted to share about how they kind of avoid that or try to protect against that? Do you want to think about that while I go to
Yeah, please.
So I think like rather than trying to ask you for the answer, like ask it the process where it got to the answer from.
Okay, that's great.
Because then
to show its work.
Yeah, first of all, it's going to show its work, and then also you're going to learn more from that, right? Because instead of just finding the answer, you're finding out like the process of thinking, which can help you get to the answer.
Perfect. I'm seeing Caitlin nod over there. Yeah.
Yeah. So what I see in ChatGPT is sometimes we ask questions like, when we are doing a question regarding like medical ethics especially, because ethics differ country to country sometimes, like the framework.
Totally, yeah.
So when we ask a question regarding ethics, it can give a very different answer.
Yeah.
Some like depending on the source it gets. So like when communicating with AI, I think it's better to provide something like background knowledge or something like a source.
To contextualize it.
Yeah.
Okay.
And to be specific and try to get the answer back.
Yep, so that's great. So giving ChatGPT more to go off of. So rather than saying, give me 10 applications of AI, hey, I'm teaching a course on healthcare and AI. What do you think should be taught, right? Yeah.
One more thing I want to mention is like, if you ask it like any questions based on like religion, it completely like, it's not unable to like distinguish like fact from like the religion perspective. So like, let's say if you were just asking like generally like, what's the correct religion, it would like have no like basis of like to answer that question, right?
Yeah.
But let's say if you ask it from one perspective, it'll suddenly like agree with you. But if you put the counter perspective, it'll also agree with that. So it doesn't like have like a subjectivity in that.
Fascinating. Caitlin?
I think this is a fun little fact, but I think I know people who've taken specific courses on how to put things into AI for it to fully understand everything.
Yep.
And what I've been told is just the more specific you are, the better the results are going to be.
So again, and we'll talk about this if we get to it, prompt generation is actually a whole art. Just like teaching, just like writing a midterm question is a whole art. There's good midterm questions and there's bad midterm questions, as I'm sure you've all experienced. There's good prompts and there's bad prompts, and that's, there's a specific art. And so the way I do it is I have, very skeptical and very leery, so I do the work myself, and then as a gut check. So if I'm doing a statistical analysis, I'll say, okay, this is what I think I should do. Tell me what you think, or tell me why I'm wrong. And then kind of going and pulling on those threads and going to a deeper analysis. And then also realizing that maybe it's hallucinating an answer, going and fact checking against that. So it ends up being more thorough, but you end up doing the deep dive and learning more to your point. Can I get a time check? Where are we?
2:42.
Oh, great. Okay, we have 38 minutes. Yes. Okay. Did you know that the New England Journal of Medicine so believes in the power of AI, they have their own dedicated AI mini magazine. So they launched this in 2023 because they saw the potential. So it's NEJM AI, there's a link. Okay, so we are seeing AI is being used. It is being used in healthcare. I have a parrot, as you'll learn. So I take my parrot to the avian veterinarian, and my vet came in and said, hey, I'm using an AI app to just listen to our interaction, it'll summarize my notes for me. And my colleagues in emergency medicine in the States are using this, and I've also seen it come into Canada. So basically, as anyone who charts knows, that charting is the bane of our existence. It takes up a lot of time. And so what the AI does is it'll listen to the interaction, it'll summarize it, and then it's up to you to kind of edit it, just like having a resident or someone do the work and you instead be the editor. So we're seeing AI for dictation, parsing, collating results, precision medicine, cancer detection, looking at quality assurance in diagnostic imaging, looking at x-rays, and looking at the rate at which radiologists may miss or underdiagnose. We're seeing it in histology and pathology, so Kim, watch out, AI is coming for your job. And we're even seeing it in ophthalmology, and even patient selection for clinical trials, because, total sidetrack, but once upon a time, a lot of the current medicine we have is based on totally homogeneous populations that may not, actually probably wouldn't apply to anyone in this room. It was middle-aged Caucasian males, which none of us are anymore. So getting that personalization and figuring out that maybe the dose of aspirin for a heart attack may be slightly less for someone like me compared to what the standard is currently. So drug matching, we're going to talk about, and even health insurance coverage and parsing large data sets. Okay, so we talked a little bit about the pitfalls. We talked about ethics differing from country to country, privacy concerns, so how secure is ChatGPT really, or any AI. Regulatory concerns, like regulatory is slow, technology is fast, so waiting for the regulatory frameworks to catch up with what is happening with the pace of innovation. And then to your point about reliability, asking ChatGPT the same question over and over and getting just different responses. If a patient did that to me and I said, well, this may be cancer, no it's not, yes it is, that would not inspire confidence, right? And then we already talked about bias in diagnosis and treatment. So I've included some links there for you. This one is from Harvard Medical School. And basically they talk about leveraging medical grade AI language models for different applications for consulting, getting insight, and getting assistance in diagnosis. Okay, so we talked about innovation. So innovation is not just technology, it's thinking about totally different ways of doing things. And so this next story seems so unbelievable. I go back every few years to check that it really is true. But this was in the BBC, and basically they turned pigeons into pathologists. And what they did, so pigeons have certain qualities that we don't. So they can see into the UV spectrum. And so they trained pigeons to read pathology slides and detect what breast cancer looks like. And so when the pigeon was accurate, they would reward it with birdseed. So it's not just different labor, it's cheap labor. And so they found that pigeons are just as accurate as a fully trained pathologist like Dr. Soles, and when they flock sourced the answer to a flock of pigeons, they actually became even more accurate than the gold standard of pathologists. So not only is AI coming for Dr. Soles' job, so are the pigeons. So here's the link. So again, not to, like, we see this everywhere in the animal world. We see canines trained to detect, to be support animals or guide dogs and provide support and detect seizures or to sniff out COVID. We see rats trained to detect landmines because they're too light to set off a landmine. So these are all examples of innovation that are super high tech, but they're just different ways of thinking. Okay, so microbes. Antibiotic resistance is a huge problem. It has been since I started teaching this course. It's happening everywhere in every corner of the world. That comes from the WHO. And it's super scary because what were considered broad spectrum big gun antibiotics when I was in medical school now have evolved resistance. And sometimes the scariest thing is when you get a culture back and all you see is R for resistance straight down. Maybe you'll see one S and you say, what do I do with this? And the problem is, as much as we're evolving our antibiotics, the bacteria are evolving and the viruses are evolving too. So part of it is an us problem. 50% of antibiotics are inappropriately prescribed, and that may just be sometimes we don't want to have to fight, sometimes we may misdiagnose something's bacterial and spiral, sometimes we may just think it's easier, sometimes there may be another reason. Sometimes someone might be immunosuppressed and we think the value judgment is protecting them rather than seeing where the illness goes. There's a variety of reasons. But the challenge is that means that we have our work cut out with us when faced with bacterial and microbial resistance. So what's really cool is the innovation needs to keep happening. So in 2015, this was the first breakthrough in antimicrobials since the 1950s. It was called teixobactin. And it was a specific aspect of a previously unculturable microbe, part of the mycobacteria family. And the issue was culturing it from the soil was previously so difficult, we weren't able to isolate the teixobactin from that microbe. And then with breakthroughs, we were suddenly able to isolate this novel, potentially antimicrobial source. So sometimes we know what the solution is, but we don't have the tools to help us extract solutions. So for those of you who want to read more about what teixobactin, here's a link to the American Society for Microbiology link where you can read more. Okay, we talked about drug repositioning. So when we have challenges with, say, cancer, there's detection, there's looking at how metastasis happens, there's looking at novel therapies. I know about a decade ago, there was some hope that glioblastoma, by starving their glucose supply, we could starve it out. That hasn't gotten very far, to my knowledge. But what about using drugs and repurposing them? So sock puppeting them. That's a potential idea, using a drug we might use for blood pressure or heartburn and looking at its properties to and its fit to receptors on a cancer cell. So that could work, but that's actually a lot of work because you have to know the 3D configuration of both your potential drug as well as the receptor. Now, with both computer modeling, with AI, with the potential to create kind of a speed dating matchup between drugs and with receptors, there's actually a whole potential use case for that. So this comes from Stanford and Hewlett-Packard. It was a collaboration between the two, and they found that in certain cases, existing drugs, so cimetidine, which is a heartburn medication, may have applications for lung cancer, and then Topamax, which is used for migraines, for seizure, for chronic pain, may be used for inflammatory bowel disease. And it's simply by recognizing what 3D configurations can match in with each other. Okay, so we talked about 3D printing and applications, and then also we talked about the principle of personalization. So who here's ever had to wear a cast? Anyone? No one's broken a bone? Was it comfortable, Dr. Solis?
No.
No, okay, so it's itchy, they're hot, if they're not put on right, and you have, like, for example, there's a divot when it sets, you're going to have that uncomfortable, hot, itchy, eventually smelly cast on you for weeks at a time. So what would be nice is if you could have a cast that's washable, that breathes, that's waterproof. And so here's an example of a 3D printed cast that is fitted to the mold of your hand. And it's dishwasher safe. So if you have two versions of this, you can put one in the dishwasher and then wear the other one and take a shower as you would while still immobilizing your broken bone. And then a Russian group said, well, what if you could make it heal faster too? And so this, what you see here, the plugins are high frequency ultrasonic waves that can, in their study, I don't know how far this went, was shown to reduce bone healing time by 30%. Yes?
I was gonna ask, wouldn't that be just like very like cost effective and also it would take longer to make?
The 3D printed cast?
Yeah, so I meant cost inefficient.
Cost inefficient. So the cost maybe is everything. Think of everything as in cost, opportunity cost. So if you have ever had to wear a cast, you may be willing to fork out the money to be able to shower without a garbage bag over your hand, without the smell, without the itch, without the heat.
Okay.
So based on the only one person who has been here who's worn a cast, what would you have done? Kim, would you have shelled out the money?
Yeah, I would have taken that in a heartbeat. Yeah.
Yeah. So, to your point, there's, look at Ozempic, the fast, easy way, so the best gold standard for losing weight is diet and exercise.
Yeah.
Okay, some people do not want to do that and will go through Ozempic. And that is a gross oversimplification, because when a patient comes into my office, they will not meet the criteria for Ozempic unless I know what their journey has been and that they have already tried something and that they've plateaued and they meet the criteria for Ozempic. So there may be a pathway and medical indication for Ozempic. In Hollywood, when the easier thing to do and when your income relies on how good you look, the easier thing to do is shell out for Ozempic. So everything is an opportunity cost. Okay, so we're going to continue on with personalization and genomics. So Harvard Medical School has a center for personalized genetic medicine. And with the advent of being able to sequence the human genome, that's cool, but that's also a lot of data. So how do we translate that data to be applicable for physicians who are busy, who have patients, who have charting, who have paperwork? And so what they did is they came up with a one-page summary of what the potential applications were. So, for example, warfarin is an anti-clotting medication. And so in the context of this patient, the genome shows that they actually might need a decreased dose requirement to start with compared to the average patient. That's useful. That's something I can use. This is how they might respond to a typical diabetes medication, metformin. They will have a typical versus an atypical response. So that's where personalization and technology and genomics becomes more important. Okay, time check please. 55, okay. How much more do I know all this? Okay, we'll kind of blitz through all of this, and then I really want to spend time on the problem-solving frameworks.
Can I ask something about the genomics?
Yeah.
When it comes to drug therapy and everything like that, doesn't it also depend on for example, the environment of the cell and the the DNA isn't usually, it's not only the piece that goes
you're very
wrong.
right. So it's phenotype. Sorry, I'm just going to grab a tissue here as we chat. It's everything from your metabolism. It can be your hydration state. It can be if you ate a grapefruit that day, right? The cytochrome. One of the cytochrome's pathways is affected by grapefruit. So if you're on certain medications, you're counsel not to drink grapefruit juice. So it is a whole host of factors. However, if I'm a physician starting someone on metformin or warfarin, I will know that if my average dose is 3 milligrams daily, I'm probably going to start this patient on 2 milligrams, and they'll give me a starting point. So it helps inform my practice. But you're very right that medicine is not as reductive as a single factor. It would be really nice if it were, but it's not. Okay, so to your point, Janine, we need to consider everything from the micro genomics to the macro and patient lifestyle. So this was a study from Duke University that looked at how people lived and risk factors for cardiovascular disease and getting a heart attack. And what they found is that divorce was a significant risk. Oh, thank you so much. Thank you very much. So divorce is a significant risk factor for heart attacks, and getting more divorces is especially high in women, and the more women remarry, the risk doesn't go down. The other thing is, you may have heard that marriage prolongs life for men, but reduces lifespan for women. So take that with a grain of salt. not to make a judgment any way or the other. Okay, I'm just going to spend a second doing this so I don't multitask. Thank you very much, I appreciate it. Okay, so this is a scene that's familiar to all of you because you've all experienced virtual work learning in the pandemic, and I would be shocked if you didn't. So in 2020, all of us lost access to our physical workspaces, training spaces, and educational spaces, without exception. So we had to learn how to overcome that, so our learning wasn't disrupted and our work wasn't disrupted. So I kind of alluded to this from actually, if my schedule allows, I'll be back in March to do AR and VR. So I talked to you about my work with Luxonic. I am the VP of Immersive Medicine with Luxonic Technologies. And what we figured out early on is that being able to miniaturize your workspace as well as virtualize it gives you access into areas where physical infrastructure is limited. So if you don't have the space, virtual reality provides an option. And it also can give you access to a learning space if you're not able to access it physically. So this was an underwater aquanaut mission I did in 2019, and I brought the Luxonic suite with me. And so if you have ever had to read diagnostic imaging, you need high resolution monitors, so that takes up space, and that takes up physical monitors and screens. So what the company has done is it's virtualized that entire workflow into virtual reality. And so I can see that all in my headset. You can kind of see it projected on the screen there. And then this is kind of where the remote access part comes into play. So I was underwater in the Florida Keys, 20 feet of depth. I was able to link up with the head of radiology in Saskatoon, Canada, and review the imaging of a simulated trauma patient and go over the salient points of it. So if you're a learner, you can also go sit in with your radiologist without needing to be beside them physically and still maintain your educational standards. Okay. So I do want to talk about, we kind of alluded to this when we talked about health. Health is not merely the absence of disease, it is the presence of well-being. So what about making ourselves better? What if we could perform better? Who here would take a photographic memory if you could get it? Yeah? I would. It would make my life better. So this is a article from the New England Journal of Medicine. This patient had hyperalimentation and obesity. So through deep brain stimulation and targeting in an area, you can actually, it's indicated for everything from refractory depression, obsessive compulsive disorder, and obesity. They were off by a few millimeters, which is kind of a big deal in brain surgery, but their patient ended up with an eidetic or photographic memory as a consequence. So, I mean, I would take that trade-off, to be honest. Okay, so let's talk about the pitfalls of other aspects of medicine. We've talked about AI, Neuralink. So this is Elon Musk's proposal to put chips into the brains of patients, starting with folks who may have maybe paralyzed or immobilized through stroke or through neurodegenerative disease. And it's given some patients a quality of life back. But there was an expose about 2 years ago where someone looked into the testing of the primates where Neuralink was first applied, and there was a lot of pain, infection, improper procedures. So any innovation that you see out there, go digging, pull on threads and say, okay, is this as good as it seems? Is this as good to be true as it seems to be? Whether you're talking about AI or memory or neural enhancement. So right now, this is more for folks who may have neurodegenerative diseases and deficits, but in the future, it may be used for folks to enhance their memory, to give them direct communication with an AI or with someone else with a Neuralink. So the sky's the limit when you imagine the future of medicine. Okay? Here's a summary of a ton of trends in medicine. We've talked about some of them. We haven't talked about all of them. And in the interest of time, I won't go through it. But one thing I do want you to spend some time thinking about is, in this era of rapidly emerging streams of innovation, whether we're talking about social media, connectivity, AI, virtual reality, I also want you to start thinking about the cross streams and how they can both build upon each other, but also where the pitfalls may lay, because that is where the future is going to be and already is. Okay, so So let's spend the last 20 minutes talking about pathways to innovation. Okay, so how do we get from here to there and create that future we want to see? Okay, so we're going to talk about 4 things: people, mindset, environment, experience. Okay, I don't know what's happening here. Okay, so when we talk about people, we talk about working in teams. Everything I do is in teams, whether I'm talking about working in startups, whether I'm talking about medicine, whether I'm talking about working in space. I have one brain. I do not have the skill set of an engineer, as well as a computer programmer, as well as a doctor. I have a certain skill set that fits in a certain missing piece of the puzzle to that team, but when I'm doing work at Luxonic, I work heavily with the developers to bring what might be a clinical application into virtual reality. Okay, so what I also want to get you thinking about in this course is thinking about your own skill sets and trajectory and what you bring to the table, but also who can help you in the gaps that you have, and building on each other's ideas. And when we get to the workshop component of this course, we're actually going to put that into practice. So the bottom line is you don't need to be a brain surgeon and a rocket scientist. There's probably a lot of synergies between each of your skill sets in this room already. Okay. And then this is more applicable, not specifically to medicine and innovation, but to everything you will ever do in life, is viewing teamwork and leadership as an ebb and flow model. Okay? It's not just simply being the leader, the person who's at the front of the room telling everyone what to do, and it's not just simply being a follower. It's viewing teams as a mortar between the bricks model, because if you think of a brick wall, it's easy to think of the strength as coming from the bricks themselves. But if there's no mortar between them, the brick wall falls down. So your job as a teammate and a leader is to be the mortar to both fill in gaps where you see them, but also build connections between the rest of the team or the bricks to help build that foundation. Okay, so now we're going to talk about innovation mindsets. Okay, so question everything. Maybe don't do it out loud, because that may not be your audience's, what your audience wants. But start asking how things can be made better, and then more specifically ask, within your life's experience, how can you make this better? So here are a few case studies. So this is an 18-year-old, this is Anna Polgarian. She was volunteering in a hospital, and she looked at dialysis machines, and she said, okay, that's great, but what if you don't want to come into the hospital? Oh, this is advancing on its own. What if you don't want to come into the hospital 1 day a week or 3 days a week to do dialysis? What if you are in a disaster area and you don't have the electricity supply, or that's too bulky to bring in a full-size dialysis machine, which is the size of a refrigerator? So she, over the course of her summer as an 18-year-old, engineered a miniature dialysis machine the size of a suitcase that was more portable and more cost affordable compared to a dialysis machine. So she did that in the context of her experience in a hospital. Here is the other question I want you to ask is, what if? Okay, so we talked about what if we didn't limit ourselves? What if we didn't limit ourselves about how we thought about bottles? It's just something to drink out of. What could the potential be? Okay, so ask big, daring questions. This isn't showing up. I think I have too old a version. But basically the case study, has anyone heard of Igneous? Oh, that's what that's doing. The case study of Igneous Semmelweis. So has anyone heard of him? So this was a guy who in the 19th century had a crazy idea, and that was simply, he was noticing that as a physician in the hospital, that after being in the morgue, physicians would go straight to the bedside of maternity wards and deliver babies, and these women were dying of puerperal fever. And his crazy idea was, what if we washed our hands in between being in the morgue with these dead infected patients and delivering babies? Which today is absolutely common sense. However, he was ostracized for this wild idea, and in fact, he spent his days alone in an asylum. And the only thing that gave him hope is this quote: "When I look back upon the past, I can only dispel the sadness which falls upon me by gazing into that happy future when infection will be banished. The conviction that such a time must inevitably sooner or later arrive will cheer my dying hour." So it was very sad how he died, but mostly looking at how we practice today, we can imagine that Semmelweis would be happy with what he sees. So the interesting unintended consequence of the first months of COVID is hospitals were so diligent about hand washing that other hospital-acquired infections like C. difficile actually went down because the rigor with which we applied infection control increased. Okay, so here's the other disruptive mindset that I want you to learn is learning to think exponentially. So what do we mean by that? When we talk about thinking and looking ahead, we can either think in linear patterns or we can think in exponential patterns. So to kind of get your gears thinking in that, if you're walking on a treadmill and you increase your rate in a linear fashion, you're walking at 1, then 2, then 3, then 4 kilometers an hour, and it's a very predictable pace. Now, if you increase your rate of walking to running in a geometric or exponential fashion, you're doubling your rate. So you're going from 1 to 2 to 4 to 8 to 16 to 32. So at first that's manageable, but by the time you make the jump from 8 to 16 to 32 kilometers an hour, how long do you think you're going to last on that treadmill? Maybe a split second before you hit the back wall, right? So the reason it's important to think about exponential change in the context of technology is because if you don't, you're actually going to be left behind. So let's look specifically at communication technologies. This is the radio. How long did it take the radio to reach 50 million people? Guesses? Anyone?
20 years.
20 years? Any other guesses?
5 years?
5 years? Okay, the guess is actually 38 years.
Oh.
Okay. How long did it take Facebook to reach 50 million people?
3 years.
3 years? Any other guesses? Little bit less than that. 2 years. Okay. All right. When the Hello video by Adele came out, how long did it take to reach 50 million people?
A week.
A week? Any other guesses?
30 minutes.
30 minutes. Somewhere in between. 2 days.
Oh.
So this is how communication technology is accelerating at an exponential pace. Okay, so let's look at some other case studies to talk about disruption. So once upon a time, don't know how old most of you are, but to get books, you had to go to the corner bookstore. Pretty soon those were disrupted by big box chain bookstores like Barnes & Noble, Chapters, Amazon. And then Amazon said, well, what if we could have an unlimited supply by just keeping books in warehouses? And that soon was a threat to Barnes & Noble and Chapters. So then what came after the warehouse?
E-books?
E-books, yeah. So Amazon became its own disruptive force because they realized that something's going to put us out of business. So we better be the thing that puts us out of business to keep us in business. And that, of course, was the Kindle. Okay, so again, dating myself here. Once upon a time, the way to get access to a movie was to go into the video store on a Friday and rent a VHS tape. I think there's one Blockbuster video in existence now, and it just stays there for a historical landmark. So Netflix sought to disrupt Blockbuster by having the mail-in DVD service. And then on the horizon, they saw streaming services. So before Netflix was ever a streaming service, they were a video mailing exchange service. And then they sought to become their own disruptive force. And now, of course, they have to contend with Hulu and Crave TV and all of the like. Okay. So thought experiments. How do we take ourselves out of the present and learn to live in different eras and times? So one of them is time traveling as a thought experiment. So this is actually a family that really did this in reality. They found that their 4-year-old and their 2-year-old were addicted to tablets and they couldn't tear them away for it. And they just realized they didn't want their kids to grow up like that. So they said, we were both born in 1986. We're only going to live with the technologies we had in 1986. They had an Atari system, they had fax machines, they had microwaves, but that was it. If they were doing a cross-country road trip, they would use a paper map. If they had to view photos of their newborn nieces and nephews, they would only take printed photos. So it's an interesting thought experiment to see how we live socially in the context of the technologies we have today. Were you raising your hand? No. No, okay. Okay, so here's a thought experiment. Jobs that didn't exist 10 to 20 years ago. Name me 3.
Already developer, like web designer or something?
Yeah. Okay, web designer, app developer.
Influencer.
Influencer, yeah, of course.
I saw the other page, so I don't know if I can say
You can
it,
say
but,
it.
I saw data analyst on there. I don't know
Data analysts. You know, those, so big data analysts. So we didn't used to have to contend with massive data sets that come from Google searches that actually give us insight into what pathologies might be seasonal, because that's the thing. So Zumba instructors didn't exist, and I don't think they exist now, but for a brief period of time in the early 2000s, they existed. Search engine optimization specialists, that wasn't a thing decades ago. User interface, user experience specialists, sustainability managers, those are all jobs that when I started teaching this course didn't exist, and now some are also kind of riding out into the sunset. Okay, so what are jobs that will not exist in 10 years or are already becoming obsolete? 3 examples.
Coding, like code developers.
Really?
Yeah.
Okay, tell me more.
I think that like slowly AI is gonna get better
Okay.
and better, and it's gonna be able to like find more ways to do it. I don't know that much about the field, to be honest.
Yeah.
But I just think that the way like AI is exponentially growing, it's eventually gonna replace coding.
Yeah, okay, that's a good one. Dom.
Some doctors like pathologist, hematologist, radiologist who can
Take the other jobs. So which
yeah.
which
Like,
physicians will still be around?
I think neurosurgeons,
Neurosurgeons. I think that's
Can
because
be
they'll refuse.
programmed.
I think that's because they'll refuse to go out.
precision.
Yeah. No, that's not true. I worked on the neuroarm robotic surgical robot. So that's a robot that does brain surgery that works at a smaller scale. So
Yeah,
maybe. Okay, let's go to the next slide. Okay, so we're already seeing this. Cashiers,
Yeah.
travel agents, we don't see those anymore. Librarians have to contend with search engines. Postal workers, drone delivery. Taxi dispatchers are being displaced by Uber and Lyft. Right now, many of these are coexisting. Some have already lost the battle, some are coming back. We've seen retail cashiers go out, self-checkout come in, some are getting rid of them. I saw a physical newspaper last week and I was shocked because I didn't think they were still around. So the world is changing, and I want you to pay attention to that because there's so much on this list that is outside of my experience that you will know of. But this may be your pathway into predicting or saving things that need to be saved. Okay, last question is, what are jobs that are going to exist in 10 years?
Doctors, definitely.
Hopefully, I hope so. Jessica?
Like maintaining technology in the sense of like drones need to be maintained or.
So we will be subservient to our AI overlords?
I guess kind of, but then when you think about it, there might be the technology to maintain the technology, if that makes sense. Like
so be
full
nice to our technology so we have a job in 10 years.
Yeah, I guess I can remember.
AI servants.
AI servants, okay. Any other guesses?
Astronauts.
Astronauts. Okay, perfect. So that is actually up there. And so this needs to be updated because this came on during the early years of the course. So I put a star by the predictions that actually now exist. So we actually do have folks who architect or code in VR and AR. That was not a common job 10 years ago. 3D printing engineers, that is a whole industry. Alternative currency, Bitcoin, crypto, Dogecoin, whatever coin you want to say is the cryptocurrency out there. So commercial second generation astronauts, that was not a thing before 2021. But now we can send astronauts to space, not just as tourists, not just as contest winners, but in my case, as researchers. So that is a whole new playground and platform in which humans can exist. Yes?
This is kind of a random question, but has there been more than 1,000 people that have gone to space?
700,
Okay.
which 12 to 14% have been women. So if any of you want to be astronauts, I wholly support it. But
Not me though, right?
no, I support it because so this is the other interesting part because prior to the rise of commercial space in 2021, it was about 550, maybe 600 folks that have been to space.
Mm-hmm.
And then that was in the entire 60-year history of human spaceflight. And now that has gone up by 200 in 4 years alone. So the prediction of when we will reach 1,000 people in space will probably be in 2-3 years.
Okay.
And then the other thing is, someone asked me, is when we will have 100 people simultaneously living in space. So to give you an example, we have been breaking the record year after year of the most people in space simultaneously with the rise of suborbital space flights, International Space Station, SpaceX private missions, what was the other one? Oh, the Chinese space station, Tiangong. So what do you think that number is when we have the latest record?
The current record, sorry?
The current record for the most people in space at one time?
I'm gonna guess 50.
50. Any other guesses?
30.
30. It's 19 to 21. So we still have a ways to go. However, with the rate at which commercial space stations are being developed, it's probably going to be, I would say, 5-6 years. Okay, so to the point of jobs that don't exist yet, Extinction Revivalists. This isn't Jurassic Park. This is a company that is actually proposing, it's called Colossal. They're proposing to bring back the woolly mammoth, which I think is probably underthought, but their proposal is to bring back some diversity to the Arctic tundra. So there's folks working on that. Okay, so coming back to the whole point of this lecture, medicine in 10 years, it could be AI driven. We will see more integration of augmented reality and the combination of machine learning with VR and AR. I don't know where we're going to be with two-tiered versus a public system. I think with current trends, there's a strong push to make it two-tiered for sure. It will be more predictive. The percentage of our population that is going to be over 50 by 2050 is changing. So we really need to figure out how our infrastructure is going to support chronic disease, degenerative disease, heart disease, all of the chronic diseases that form a significant portion of healthcare costs. And then we're going to have to become more refined and get new positions to help people navigate healthcare. Because when I help family members navigate medicine, it's because I know the system. It's because I know what the physician versus the hospitalist versus the nurse versus the physiotherapist does. But as we get more specialized, we're going to need subspecialties. But we're also seeing the rise of more pushback and more pseudoscience. We're also going to contend against that. And then maybe personal enhancement as well. We're probably at time, yeah? What time is it?
A minute.
I have a minute, okay. So I am going to,
You'll have to come back in March.
I will come back in March, okay. So the rest of this is all about problem solving frameworks, but this is the last thing I want to talk to you about is mindsets, is how do you develop that mindset? I think the simplest thing you can do is start going about your day with a pencil and a notepad and say, how is this inefficient? How can this be made better? How can I make this better? What about the traffic flow of students between classes? That tends up to be a huge bottleneck. Maybe that's something that you can solve, okay? So I'll just end with the environment and experience piece and then you guys are free, okay? So this is a study from Harvard Business Review. Coming here. And it looks at how the best innovators and what their traits were. They make associations between unlike concepts. They question everything. They make observations, and then they experiment, and then they find other people and network and build upon those ideas. So it doesn't matter how old or how young you are. We talked about the case of the 18-year-old who built a new dialysis machine. This is a 91-year-old designer who took her experiences in the nursing home to help the leading design firm build pill bottles that are easier to open. Okay? So innovation comes from everywhere, any experience, and can come at any level of technological advancement or even new ways of doing things. So with that, I'm going to cut you guys free. This is basically an introduction of all that is out there in medicine, and it is a lot. That's pretty much the only thing you need to walk out with. But there are ways to be a part of that if you choose to make that part of your career, and you can do that both in the context of your own experiences, keeping abreast of the technologies that are emerging, the crises that are emerging as well, and then asking, how can this be made better, and asking, what if there was no limit? That's all I got for you. You will have access to these slides, and I may or may not be back. Thank you.
Thank you.
Wonderful.
It was hot. How did they fit 13 people in here?
They don't.
They don't. There's no way. Okay.
Yeah.
Just a quick